Everyone, I wanted to go over algebraic expressions with you from the lesson 2.1 material. Let's start off with the following example. Recall that an expression is a collection of variables and numbers, but they are not equal to anything in particular. So if there was an equal sign that was included in here, then that would mean that we have an equation, but in this case we are working with an expression. So one of the first things that I want you to note here is that a couple of these terms, in other words, the values that we have in there that are separated by addition or subtraction signs, both have x's in them. In this case, one of them is 6x and the other is negative 19x. Note that when I did the circling, and as I just referred to it, the 19 will keep the negative sign in front of it. The sign that is out in front of your value is attached to that value. So what I'm going to go ahead and do is rearrange this to kind of help me along. You don't necessarily need to do this in your work, but since I'm doing a full explanation, I figured I will give you full detail. So here we would have 6x minus 19x plus 5 minus 4. So the reason again why I'm able to do that is because this is really essentially one giant addition/subtraction problem. So I'm allowed to use the commutative property. In other words, I am allowed to rearrange the terms in that addition/subtraction problem. This allows me to combine like terms. That's probably a piece of terminology that you've heard of before. So here we can basically treat it like a counting problem essentially. If I have 6 x's and I take away 19 x's, this would leave me with negative 13x. Okay? And then if I have 5 and I take away 4, that leaves me with a positive 1 left. So the answer, after I finally clear everything up, is going to be negative 13x plus 1. Again, you may be tempted to try to solve for x, but remember you are not able to do this because this expression is not equal to anything. So you don't know what negative 13x plus 1 is equal to. If you don't know what it's equal to, you cannot solve for it. Let's go ahead and take a look at a problem that's a little bit more challenging. We're going to work with 9 times the quantity 4x minus 5 minus 6 times the quantity x plus 9. Our goal is very similar to the previous problem. We want to simplify this down. Notice that we have x's scattered everywhere, we have numbers scattered everywhere. We want to see if we can summarize it a little bit better. So in this case, we need to get rid of the grouping symbols, or in other words, these parentheses. And the best way to do this is using a property called distribution. So in the first case, I'm going to go ahead and distribute that 9 to each of the terms. So remember, this is kind of like an Oprah's favorite things. In order to get rid of the parentheses, everyone in that grouping needs to get a 9. So you get multiplied by a 9, and you get multiplied by a 9. So in this case, 9 times 4x gives you 36x. 9 times negative 5 gives me negative 45. For the next one, we need to distribute the entire negative 6 to each term. Again, just like we had talked about in the previous problem, the negative is attached to that 6. If we do not distribute the 6 along with its negative, we are creating a sign error, so our answer will be off. So negative 6 times x gives you negative 6x. Negative 6 times positive 9 gives you negative 54. Okay, so I'm going to go ahead and rearrange this again, since I'm doing a full explanation. And again, this allows me to see that I can combine like terms a little bit easier. So 36x minus 6x gives you 30x, and then negative 54 and negative 45, if we add those or combine them together, we get negative 99. So there is our final answer. Okay, so let's move on from here. And the last thing that we're going to look at will be problems that ask you to evaluate. So in other words, you want to produce a final answer. So let me give you a question to work with. So let's start off with 6x squared minus 3x. This is your expression, and I'm going to tell you I know that x is equal to negative 4. Okay? So if you're asked to evaluate, and you know what x is equal to, really what you're going to do is you're going to substitute everywhere you see an x, you're going to change it out or switch it out for a negative 4. Okay? So in this case, I'm going to rewrite the problem. So I have 6 times the quantity of negative 4 squared minus 3 times negative 4. Alright, and from here we would use order of operations to clean everything up. So the first thing that we would go ahead and do is notice that there's really nothing that you can do to clean up the parentheses, you just have one number sitting in there. So the first thing that I would suggest doing is squaring. So this leaves us with 6 times negative 4 squared. So notice that the negative is included inside those parentheses. So negative 4 squared is negative 4 times negative 4, which will then give us a positive 16. And then we have minus 3 times negative 4. Now we can go ahead and continue down the list of order of operations, and we will go ahead and tackle multiplication. So 16 times 6 gives us 96. And then we have a negative 3 times a negative 4, so this turns into plus 12. And then 96 plus 12 will give us 108. There's your final solution. And again, we can do this with other numbers. Like I could switch this out and say something like, well, what if x is equal to 2? A positive 2 specifically. So again, we can go through our problem and say, well, everywhere that I see an x, I'm going to switch it out for a 2. And then we will go ahead and take care of order of operations. So here we have 6 times 2 squared, which will give us 4. And that would be minus 3 times our 2. Now we can take care of multiplication. This results in 24 minus a negative 3. So in this case, a negative 3 times a positive 2 would give you that negative 6. And then 24 minus 6 gives us 18. And there's your answer for that case. I hope that this video was helpful. If you do have any other questions, please let me know.